All right, guys, got exponential functions today, functions with exponents in them. Let's check it out. First of all, an exponential function is when basically your x is your exponent. That's where your variable is. F of x equals a to the x power. A has got to be a positive number, and it cannot equal 1. If it equals 1, obviously the whole thing equals 1 all the time. So it's got to be something bigger. Does not 1, must be positive. I would say bigger than 1, but that's not true. It could be a fraction that's bigger than 0. All right, now exponential functions grow very quickly. Look at these. Using 2 as in my a, and as my exponent as my x. Look what 2 cubed is. 2 cubed is 8. By the time you just get to 10, look what the function is, 1,024. When you get to just 30, you're already in the billions there. It's crazy how fast they go. Exponential functions grow exponentially, all right? They grow really, really fast. All right, we're going to evaluate some. And that's the first part of your assignment tomorrow. No big deal here. F of 2 just means you're going to plug in the 2 for the x. 3 squared is 9. We're going to use the calculator to help us here. 5 to the negative 2/3. You just punch it. Sorry. F of negative 2/3. Easy for me to say today. Is really 3 to the negative 2/3 power. Punch that straight in. You get this decimal right here, 0.4807. Don't forget what this does, by the way. The negative flips it, which makes it really 1/3. 3 is cube root, so I'm doing the cube root of 1/3 squared. That's what that really was. F of pi, put pi in for your exponent right there. If you put pi in, punch it in. I'm punching it in real quick. 31.544. You might want to punch them along with me to make sure you're getting the same thing. And if you put in the square root of 2, and punch that in, 3 to the square root of 2 power, getting 4.7288. You might have to check those on your calc to make sure you're good doing that. All right, so let's keep going. Draw the graph of each. Now, the graph of 3, let's start with 3 to the x. I'm going to put in, I'm just do a little xy table here. Let's say I put, negative 2. If I put negative 2 in there, right here for that x, that means I'm going to square it and flip it, which is 1/9. If I go to negative 1, I'm just going to flip it. That's 1/3. If I put 0, anything with 0 power is 1. If I put in 1, 3 to the first is 1. If I put in 2, 3 squared is 9. Okay, so here I go. I'm just going to plot those points. 0, 1, negative 1, 1/3, negative 2, 1/9, 1, 3, 2, 9. If I start connecting those dots, it's going to look like this. Look how fast it grows. This goes left to right. Also, notice I start putting in negatives here. Notice what I got. The graph is never going to go below the y-axis. Never, because I cannot make that positive 3 become negative using an exponent. So let's try the second one. Make another xy table. Use the same numbers, negative 2, negative 1, 0, 1, and 2. All right, negative 2 means I would take this right here, I'd flip it and square it. That's going to be 9. Plug in negative 1, just flips it. That's 3. Anything in 0 power is 1. If I put in 1, I get 1/3. If I put in 2, I'm squaring it, I get 1/9. So it's going to be just the opposite. Negative 2, 9. Negative 1, 3. 0, 1 still. 1, 1/3. 2, 1/9. So it's going to do this. It's actually going to fall left to right instead of grow. Again, it's never going to go below the x-axis because there's no way to make the y's negative down here because I've got a positive 1/3, just like I had the positive 3 earlier. It's just basically the reflection of that graph. All right, so the red graph. A couple things to notice about the graph. First of all, I went through 0. Both of them went through 0, 1 because anything to the 0 power is 1. Also, the x-axis is going to serve as an asymptote because your graph can never go below it. It's going to get closer and closer and closer to it, but never touch it. And it's going to grow really fast. All right, I just couldn't pass up this picture. I loved it so much when I was little. It's very colorful, very neat, all that kind of stuff. Basically, what it's showing you is whatever the number is, like the 2, the 3, the 5, the 10, what those numbers do is they make the graph grow faster and faster and faster. Notice all of them converge right here. That point right there is 0, 1, because anything to 0 power is 1. But then the bigger the number, the faster it grows. Same thing is true over here, except kind of backwards. The smaller the fraction, the faster, it's going up, or the faster it falls, I guess you should say. So if you see the 2 and the 1/2, they're basically reflections of each other. The 1/3 and the 3 are basically reflections of each other. 5 and 1/5, just reflections of each other. And again, x-axis, asymptote. Here's basically the definition of the rule. This exponential function where a is positive and not 1, the domain is all real numbers. The graph goes left and right forever. Remember, the domain is how far left and right it goes. And the range is from 0 to infinity because the x-axis is an asymptote. It never goes below there. And look at the point again, 0, 1, 0, 1. Okay, so if it's positive, if the A is bigger than 1, if A is bigger than 1, it's going to go up left to right. If A is less than 1 or a fraction, it's going to go down from left to right. All right, it says find the exponential function. So now we're going to go backwards. They're going to give me a graph and ask me what the function is. So one I know that 25 is my y and 2 is my x. So I'm saying 25 equals a to the second power. I'm using that function right there where y. You see what the y and the x is. I just plugged them in. So I'm thinking, okay, what squared is 25? Well, 5 is. So I know by looking at that, a is 5. Technically, it'd be plus or minus 5, but our a's have to be positive. So when it says what is the function is 5 to the x power. That's that function because that's what a is. Here, this one's going the other direction, so I'm going to do the same thing. I'm going to plug the 1/8 in for the y, plug the 3 in for the x. So what am I going to cube to get 1/8? That's what I'm asking. Now, if you don't know that in your head, if you can't figure that out, the way you solve it is you raise, darn it, I'm not sure why that happens all the time. What I'm going to do is I'm going to raise both sides to the reciprocal power. I'm going to raise this side to the 1/3 power, this side to the 1/3 power. Over here, they just cancel each other. So it really means what is the cube root of 1/8? Remember, bottom is the root, top is the power. The cube root of 1/8 is 1/2. There's my a, that's what I need. So my function is f of x equals 1/2 to the x power. That's what they're wanting. What is the function of that graph? All right, a couple more things here, almost there. Use the graph of f of x equals 2 to the x to sketch the graph of this. These are the things we've always done. These are those transformations. This has a +1, which means it's going to raise the whole graph up 1. Okay, so instead of the asymptote being at 0, now the asymptote, there's my asymptote now. And usually it goes through 0, 1. That point's been moved up. So the graph's just going to go just like that. I should have done one more thing. Let me take that back real quick. I should have done one more thing. If I plug in 1 into that original function, 2 to the first power is 2, so it'd go through 1, 2. That'd be a point. So if I move that up, it'd be 1 there. I hope that makes some sense. I just kind of taught that real quick. But again, if I plug in 1 into that x, the original one, 2 to the first power is 2. So it'd go through the point 1, 2. So I'll just move that point 1, 2 up to 1, 3. Let me change colors here for the second one. This one has a negative in the front. Don't forget what a negative in the front does. Negative in the front reflects across the x. So it's going to be the same graph as this original one, except it's been reflected. So the x-axis is an asymptote. Instead of going through 0, 1, it's going to go 0, -1. And if I plug in 1 here, if I do 2 to the first power, it's 2. If I do -2 to the first power, it's -2. So it's going to go here. X-axis is the asymptote, and it's going down instead of up, okay, because of negative in the front. And the last one, right here. Let me change colors again. Let's go green. It's got a -1 in the exponent, which means it's going to shift it right 1. So I'm going to take all my original points, which I didn't draw. I should have drawn the original graph. Usually it goes through 0, 1. Now it's going to go through 1, 1 because it's been shifted 1 to the right. Again, usually if I put 1 in there, it'd get 2. So 1, 2 is going to be shifted 1 to the right, make it 2, 2. The x-axis is still an asymptote. It's been shifted 1 to the right. So basically, the same transformations we always use, those gestures we did for so long now, have done for so long now, still apply. Okay, the last thing today is compound interest. They put this in this section because it is an exponential formula. Guys, this formula right here, compound interest, is one of the best formulas invented by man. Money grows. If you can get your money growing exponentially, oh my gosh. I would love to spend a whole day talking about just this one formula because it is that awesome. Let's go through the letters real quick. The A of T basically means how much you have after T years. P is principal. Principal means how much money you start with, your starting amount. Your R is how much interest you're making, your rate of interest. N is the big deal. How many times a year is it being compounded? And we'll talk about that in just a second. T is number of years. How many years you can leave it? Now, let's go back to the N a second. The number of times compounded per year. Most banks, if you have your money in the bank, chances are it's compounded quarterly, which means 4 times a year. Every 3 months, you should get something in the mail that says, now you have this much money in the bank because we gave you interest like every 3 months. And that's usually what banks do, is quarterly, but different types of investments give interest at different times. So, and again, number of times your interest compounded per year. All right, here's what the problem is going to look like. It says a sum of 1,000 is invested at a rate of 12% per year. So there's my principal. There's my principal. There's the rate. Find the amounts in the account after 3 years. That's my time. If interest is compounded annually, semi-annually. It keeps moving on me. Quarterly, monthly, daily. So that's like 5 or 6 different things. I'm going to show you one and just show you the answers to the rest. Let's do quarterly because that's the one I've been talking about the most. So I would do this. I would do A of T, which is final amount, is $1,000 times, did it again, 1 plus the rate over N. N is how many times a year it's compounded. Quarterly means it's compounded 4 times a year. So I'm going to put a 4 there. And then my exponent number is 4t. So I'm going to do 4 times time, and time is 3 years, which is really a 12 out there. Now, if I'm punching this in the calculator, which I'm about to, I would do this. I would keep that there. I would keep this here. Now, when you punch this part in, you're going to need that fraction in parentheses. And I would go ahead, if I were you, to multiply that exponent outside. Just put 12 there. All right. Then if you punch it in, actually, it's already been done down here for you. I don't know if you can see that. It was $1,425.76. So after 3 years, you made $425. Pretty good for doing absolutely nothing, just interest only. And the reason it's called compound interest is because what they do eventually is you put interest on top of the interest you made. So the next quarter, not only will you make interest on the 1,000, you'll also make interest on the interest you've made. So it's called compound interest. That's kind of complicated to talk that way. But here's all the answers. And again, they worked out the formula for you here. Annually means 1 time a year. So like they put a 1 there and a 1 there. Semi-annually is twice a year. N is 2. Look what happens the more times you compound. The more times you compound it, the more money you make. Monthly is 12 times a year. Boom. Daily is 365 times a year. All right, so the more times you compound it, or the bigger your interest rate, or the more time you leave it in, the more money you're going to have. Fascinating stuff. Love that kind of stuff. Anyway, we'll work on all this stuff tomorrow. Can't wait to see you. See you then.